So for today, we selected a few problems to go over out of the yellow packet. And the first one the kids would like to see is number 14. Now, I'm not going to do the problem for you. There's already a key, and I was surprised there was always 3 or 4 kids in each class that like, what, there's a key? Yes, there's a key. It's been posted the whole time, okay? So if you haven't looked at the key, look at the key. But number 14, I want to do one of those. It's a really good idea. It's called the careful test for a reason, because you got to be really careful. So I know some of you are going to be like, well, I've already done it. That's why I'm going to do a different one, okay? F of x plus h minus f of x. You don't have to write this down. You can just look at it on the board. All over h. Here's what you'd have to write down. The function given, in my case, is going to be 7x squared minus x. That's my function. Can you do the difference quotient to it? And if you don't understand what that means, you're going to put in x plus h first. Then you'll subtract the original function, which is this red one. There's a lot of mistakes made in that subtraction because they forget to distribute. And you divide everything by h. This is the careful test. Everybody should try one with me right now. The one on the board. Pausing. So, this one is a commonly missed question. Let's see how you did. 7 parentheses x plus h squared minus parentheses x plus h. Anybody realize already that you've made a mistake? Okay. So now I'm going to not, here's the next classic mistake people make in algebra. They think I can just square both of these. So this is x squared plus h squared. No, it's not. It's x plus h times x plus h. That's what that really is. So it's got 4 parts to its answer, and then you times by 7. All right. This negative I will distribute now, and I have negative x minus h. And I still haven't even done my minus f of x or my divided by h, so maybe I should do that now. So now I'm going to do my minus f of x. So here's minus, and I'm putting f of x in parentheses. A third place for kids to mess up. Did you remember to put it in parentheses? Raise your hand if you remembered to put the function in parentheses. Okay, good. And then that's all over h. All right. So let's see who survives to the very end. This one is x squared plus 2hx, or xh, that doesn't matter, plus h squared. And then they all have a 7 on them. 7, because of this 7 here, I'm going to distribute it out. This will be 7 times 2 is 14, and this will be 7h squared. Minus x minus h. Now I'm distributing this. Minus 7x squared plus x all over h. And now at this point, if a lot of things don't cancel, you've probably messed up. On the other hand, if a lot of things are canceling, then you can go, I'm probably on the right track. Look at those. They're canceling. Look at that. They're canceling. Okay. Now, what I've got left is 14hx plus 7h squared minus an h all over h. And if you got stuck here, I'd be like, man, you never even learned my favorite thing. There's an h in everything. You factor it out. If you can factor it, you should. Notice there's a 1 there at the end, because when you factor an h out of an h, what you're really doing is dividing them all by h. Okay. So it's all over h. And then h cancels h. So there's your answer. 14x plus 7h minus 1. Raise your hand if you had that one right. Ooh, lots of you survived. More than half.
You didn't even do it.
Okay.
What do you mean?
Okay, gentlemen.
Way before you finished.
Okay, the next one we're going to look at is number 17. Now, I'm not going to do that problem, but I'm going to do one like it. So, everybody write this one down on that blank notability doc, as soon as I get them started. On that blank notability doc. And it is 4x squared minus 8x is less than, let me think, it's 2, 3, 2, is less than 12. Okay, now I know you asked for help on it, but so I'll give you some help. First step is subtract 12. Second step is if you can factor it, you should. Then third step is you make a number line for it, because I see this arrow in here, you know, like a less than sign. It looks to me like the end of a number line. So then you're going to probably have two things on your number line, and you got to test intervals. Let's practice that one, everybody. Pause for a second while you do that. So let's get started, see if you're on the right track. You subtract 12 from both sides. So then, why do I do that? So it's equal to 0. All quadratics need to be set equal to 0 before you start working with them. This is technically less than 0, but either way. Now I've got a 0 on one side. And now if I can factor it, I should. And I noticed that 4 goes into everything. Did you notice that 4 goes into everything? That was a really good simplification step. You didn't have to do that, but it sure makes it a lot easier later. And then I can factor it one more time, x minus 3, x plus 1, and so now I have two answers, negative 1 and positive 3. Circle them, don't fill them in. Why don't we fill them in? It says less than 0, and those are called zeros. They will make the equation equal 0, so you don't want them. They are empty, because you don't want equal to 0. You want less than 0. And now I have two ways to do it. My favorite way is to graph it, because I know it's a parabola. Goes through these spots. And then I say, where is that parabola less than 0? I think the answer is in between these two. Raise your hand if you said the same thing. Cool. And if I test a number in there like 0, you can test it by just sticking the 0 in the function. I put a 0 here, I put a 0 here, and then this whole thing is 0. Is 0 less than 12? Yup, it worked, so then I know it shades in there. And if the final answer was wanted in interval form, it would look like that. If they wanted the answer as a, what do they call these? Thank you, set builder. I could make it a sandwich because it's just between two numbers, but you always have to use less thans to do that. Negative 1 and 3. Or if I wanted to list them both separately, I could do it, but I'd need an intersect for this kind, because that's where those two things overlap. Any other things you want to ask about this type of question? Okay, so then that was 17. Let's go to 19. Everybody find number 19. We will do another one like number 19. So this fundamentally is, there's two things you could be messing up on. One is if it's just plain, I don't know how to do polynomial long division, then you have one issue. Another thing might be when there's like complicated polynomial long divisions. All right, I'm going to go with the assumption that you know how to polynomial long divide, but it's just when they're complicated. All right, so I'm going to give you this one. X to the fourth minus 3x to the third plus 2x squared minus 6x. And now, sometimes the challenge is just even knowing what to put out there. Like, what do you put out there? Well, we'll tell you something like, oh, by the way, 0 is a root. Now, you could go, okay, so you want x minus 0 to be a factor? That's true if I say 0 is a root, x minus 0 is a factor, but what's x minus 0 really? It's just x. And isn't it kind of weird to have just an x out there? Well, you could do it, though. Isn't it just going to be factoring out an x out of everything? Yeah, so maybe you could do that a better way than long division. Okay, so I would have just started this problem right off the bat by factoring out an x. Everybody do that. There's an x in everything, and the whole point of the problem is to factor it. Polynomial long division is just a way to factor things. Factoring.
Coop.
What'd you get when you factored it?
X times x squared times 2x squared plus 2x plus 6.
Nice. Now, what the heck did I do with that x down at the bottom? Well, I'm just getting ready to put my final answer down there. Do you get if I just like take off the x and don't put it anywhere? That'd be bad. I gotta have that x in my final answer. I just factored an x out. So it needs to go somewhere. So I'm just writing it down there so I won't forget it. Okay, now let's do the polynomial kind of long division. When I tell you that one of the factors for this, let me think, is 3. One of the factors for these is 3. Now wait. One of the roots is 3. If the root equals 3, then what's actually the factor that should go out there? X minus 3. Now do polynomial long division and see if you know how to do that. And I'm going to just move this stuff down to have more room. When I'm all done, your answer is something that's factored out all the way, so I'm moving this down just to give myself more room. Whoa, both things dropped out. Owen, what should I do? To keep going, I gotta...
You just drop the plus 2x minus 6 down.
bring them both down. Very good. If 2 things dropped out, you can bring down 2 more things. Okay? Now I gotta think, what should I put at the end? I think it's a plus 2. Does anybody else think the same thing? Good. 2 times x, 2x. 2 times the negative 3, negative 6. Opposite, opposite. Wait a minute. Opposite is negative, opposite is positive, and that's 0, 0. I have a 0 remainder. Yay. What does that mean? That means I factored it at x squared plus 2 and x minus 3 were factors, and then there it is. Now, a couple little questions about that. What degree is that polynomial? Was your original one a degree 4 polynomial? Yep, that'd be a thing to check. Next thing. What were 2 of the real roots? 0 and 3. Okay. Those will not be real. Now why? Because you'll end up needing a square root of a negative to get the answer. Because like you can't put anything in here that makes it 0. You can't put in 2, you can't put in negative 2, you can't put in the square root of 2, you can't put in negative the square root of 2. None of those would work. You need an imaginary number. Another way to say it is x squared plus 2 can't equal 0 without some sort of magic or imaginary numbers. Okay. All right. Yes?
So how would we write that down as k equals 0?
What would the question be?
Well, if we look at the 19, that's use the long division to find their x-intercepts.
Okay, so what are the x-intercepts here? On this problem?
X equals 0 and then x equals 3.
Good, and the other ones aren't x-intercepts because they're imaginary.
So just don't write them.
Well, if the question is what are the x-intercepts, you would only list the real ones because the imaginary ones aren't x-intercepts. Yes?
Would you have to say that they're like extraneous?
No, they're not extraneous.
Or like imaginary?
They're not real.
Not real.
If they asked you for the not real roots, you'd solve this. Here, I can finish it if you want. X squared equals negative 2. Square root both sides. Then this is absolute value of x. Then you got to know that that splits into 2 things. But wait, before I do that, I'm going to take that negative out and put an I here. You guys remember how to do that? So if you have a square root of a negative, like I had square root of negative 4, that's like square root of negative 1 times the square root of 4. Part of it's real, part of it's not. Square root of 4 is 2, square root of negative 1 is I. So by taking this square root of negative 2, let me do it since somebody was asking about how. I'm going to show you. I could just split this into 2 square roots. Square root of negative 1, square root of 2, and that's I. So it's I root 2. Now, I haven't finished though because this is an absolute value. So now I have x equals I root 2 and x equals negative I root 2. And if you wanted to munch them both together, there's one positive and one negative, so I could say plus and minus I root 2. Those are your two imaginary answers. Okay, that was number, was that 19? Okay, and now another one like number 20. Negative x squared minus 4x minus 3. Is that what they had? Nope, good. All over x squared minus 9. You should be able to tell me the x-intercept. It's where y is 0. The y-intercept, it's where x is 0. Vertical asymptotes, they make the bottom 0. And horizontal asymptotes, I'd ask Bob about those. If it's a Bob, a Sob, or a Bot. To make sure that you don't get stuck on this for too long, did you know that you're supposed to factor out a negative 1? Now, you can do it other ways, but man, this is so much easier. Factor the negative out, and you'll have x squared plus 4x plus 3, and then that factor's so much easier. Pro tip, factor out just a negative 1. Then you can factor it the rest of the way. Saloni, what'd you get for factoring the top and the bottom?
Oh my god, x plus 1 and x minus 3.
Now I should bring the negative down here like you said. So there it is. But it's not going to really affect what's in the parentheses. And then on the bottom? I'm just going to make these line up right on top of each other nicely. So then that creates a hole at negative 3. And if you didn't notice, there's a whole lot more to this problem. Everybody find the hole. There is a hole in this function. Pausing. Okay, so here we go. The x-intercept is where y is 0, and that means that this is complicated, so pay attention. If I want x-intercept, I want y is 0. That means I want the top to be 0. This is where your x-intercepts live. It's what makes the top 0. So in that case, it's negative 1 is what makes the top 0. So negative 1 is an x-intercept. And if it's an x-intercept, I know its y is 0. So negative 1 comma 0 is the x-intercept. Okay? The vertical asymptotes come from the bottom. If you're taking notes, you're smart because you'll have something like this tomorrow. And if you didn't know, that's where the vertical comes from. X equals 3. That was the vertical. And then the y-intercept is where x is 0. That means put in a 0 wherever you see an x. Well, my remaining function here, just a second, I need to move this down to make space. Or my remaining function here after I canceled stuff off was x minus, plus 1 with a minus in front over x minus 3. And that, when I put my y-intercept, which is where x is 0, that'll tell me what y equals. Y equals all that, right? So then it's negative 1 over negative 3, cancels the negatives, 1/3. Who had 1/3? 0, comma 1/3. You were right. Nice work. Do you get how I did that? I put in the y-intercept was where x was 0, so I put in a 0 where the x was. All right, next up is the horizontal asymptote. Is this a Bob, a Sob, or a Bot? You can always do this before you cancel things or after you cancel things, because if you cancel things, the top and the bottom are reducing by the same amount. So this is degree 1 on the top and the bottom. This is a sob, same on both. What is the lead coefficient? It's a -1 here and a 1 here. So y equals -1. Because this was a sob, you don't have to write sob. You have to write y equals -1. You could put over 1, but that's kind of unnecessary. And last but not least is the whole. The whole was at negative, what cancel? Oh, there it is. -3. So -3, comma, and then you put in the -3 here and here, and you end up with 3 plus 1 is 4, and then it's negative. So -4 over -3 minus 3 is -6. Negatives cancel. 4/6, aka 2/3. Can anybody verify 2/3? You got the same thing? Uh-oh, something's wrong then.
It's -3 plus 1. So
Oh, -3 plus 1, thank you. -3 plus 1 is -2, and then there's a negative in front of that, makes it +2. Oh, really messed that one up. Okay, so 2 over, at least it was there a -6 on the bottom?
Yeah.
Okay, so then do we get -1/3?
Yeah.
Okay, good. Yeah, at least you didn't just follow me and assume I had done it right.
I would have.
-1.
I'll follow you to the ends of the earth.
Well, don't worry, all that's cool. But on the test, I won't be telling you answers that are false because I won't be telling you any answers. All right, so that kind of covers a lot. Now, did I cover everything? No, but I want to leave some time for individual questions. So that is all I have for our review for the final. And hey, from here on, it's just you asking me questions and you taking the final and then you getting the results back. And then I want you to picture, because you studied really hard tonight, that you will have 75% right on the easy ones and 75% right on the hard ones. That's not that hard to do. You just need 3/4 of them right. The easy ones and the hard ones. It's R2s and R3s, you know? So,
Questions are there?
doesn't matter. So then, you get 3/4 of the easy, 3/4 of the hards. Shh, she's not supposed to talk to you about the final, of course. And then you can just envision that that's not that hard to do. You could do that, and then you got a straight A in the final, and that'll raise everybody's grades just a touch, because percentages don't matter. If you get a straight A on your final, your percent had, if you would have lowered your percent, that meant you had higher than a 95% going, which is irrelevant because 92.5s or better are straight A's. So if you get a 95 on your final, it can't help but help you. So everybody's going for the A. Is there such a thing as a 90% on the final? Yes. So in other words, it's not just 95s or 85s. There is a 90 level where if you get just a few too many wrong, like you miss it by 1 or 2 questions, miss the straight A, then you'll have a 90. Okay, so there's 95s, 90s, 85s, 80s, 75s, 70s. And hopefully we don't have anybody envisioning doing worse than that. So, all right, that's all I have for you for today. Study hard tonight.